So for geometry related questions on this exam, a lot of times we're going to be using special right triangles. And there are just a few that you need to really memorize, the ratios of the sides. First we have the 45, 45, 90 triangle, where the ratio of the sides is x, x, and x root 2. The next special one would be the 30, 60, 90 triangle, where opposite the 30 would be your x value, opposite 60 would be x root 3, and the hypotenuse would be 2x. These two equations, they're given in the front of each math section of the SAT, so if you were to forget, you can always refer back to that, but really it's really easy to memorize, so I really recommend you guys just commit this to memory. There are three more special right triangles that you should memorize. There's the 3, 4, 5 triangle, there is the 5, 12, 13 triangle, and finally, this is a little less common, but there's the 7, 24, 25 triangle. And these are all the ratio of the sides, so basically the idea is we want to eliminate having to do the Pythagorean theorem as much as we can. And so if we can recognize these ratios, we can just automatically figure out, given two sides, we can figure out the third side using these ratios. We have the 3, 4, 5 triangle, or we have multiples of them. So for instance, if they give you 9 and 12, then we know that the hypotenuse would be 15, because 3, 4, 5 would be the base ratios, but we just multiplied each of them by 3. So 3 times 3 would give us the 9, 4 times 3 gives us the 12, 5 times 3 gives us 15. It also works for these two as well. For instance, if we get one of the legs would be 10 and the hypotenuse is 26, then the other leg would be 24. Again, the base ratios would be 5, 12, 13, and we multiply each of them by a factor of 2. So make sure that you memorize these ratios, make sure that you're able to see them. It's really helpful. To give you an example, let's say I give you, let's pretend I drew that correctly. Let's say that there's a rectangle inscribed within a square. Or I'm sorry, a rectangle inscribed within a circle, rather. And I gave you that this length, or the width of the rectangle, is equal to 4. And let's say that I gave you the radius of the circle is equal to 2.5. I could ask you, what is the area? What's the area of the rectangle? Well, if we were to draw the complete diameter of this, they'd be 2.5 and another 2.5, or the hypotenuse would be 5. I'm going to redraw that triangle. So this would be 5, this length would be 4, and since we know that it's a rectangle, this would be a 90-degree angle. Well, take a look at which one of these would help most. We have a ratio of 4 and a hypotenuse of 5, so this automatically would be 3. So to find the area of the rectangle would just be base times height, or 4 times 3, which would be 12. So it really eliminates having to do a lot of algebra work or a lot of guesswork. Just make sure you know these ratios and you should be good. One thing to, or a few things to note about the 45, 45, 90 and 30, 60, 90 triangles. If we have a square, we can break that up into two 45, 45, 90s, or potentially we could break that up into 4 45, 45, 90 triangles. Even further, we could break that up into 8 45, 45, 90-degree triangles. And I really recommend that you draw this out really nicely on graph paper and maybe a ruler and kind of get familiar with how that works, maybe once, just so that you can see. For an equilateral triangle, we can cut that in half to make two 30, 60, 90 triangles, 30, 60, 90, or we could cut that up further as well, and we get 6 of them. So it would be 30, 60, 90, and we have 6 of those identical 30, 60, 90 right triangles. And if we were to have a perfect hexagon, which means each of these angles would be equal and each of the sides would be equal, we could come up with, sorry I drew it a little off, but each of these would be equilateral triangles. So a perfect hexagon is made up of six equilateral triangles, and each of those equilateral triangles could potentially be broken up into 2 or possibly 6 30, 60, 90 right triangles. So you can see all of these shapes, they kind of relate to each other. When you have a square, you probably want to be breaking that up into 45, 45, 90 triangles. If you have a hexagon, you probably want to break that up into equilateral triangles. If you have an equilateral triangle, you probably want to break that up into 30, 60, 90 triangles. And for rectangles, be on the lookout and see if you could break that up into these special ratio right triangles. Again, the 3, 4, 5, the 5, 12, 13, or lastly the 7, 24, 25.